Hello, so today we are going to talk about strokes. So, stroke are ischemic infarcts in which some part of the brain does not get their blood supply, and due to that reason, the brain starts to die. Now, whenever you are presented with any type of MRI and you are suspecting stroke, the first thing that you want to look upon is something called a DWI, which is the diffusion wave imaging. So, let me pull up a DWI image. So this is a DWI. I'm sorry, this is the DWI. So I have three of them over. So this is a DWI with high B value, DWI with low B value, and the corresponding diffusion coefficient image, also known as ADC. So DWI and ADC are basically mirror images. So many things can look bright in DWI, but everything that looks bright in DWI is not a stroke. Those things which look bright in DWI and dark in ADC are definitely strokes. So let's see what's the news here in our patients. So as I scroll, everything looks good. Both of the upper parietal region of both of the hemispheres appears good, and then as I scroll down, you can see in DWI image there is already an enhancement. I'm so sorry. There's already a high signal intensity in large territory in the MCA region. One of the peculiar thing to notice is that anterior cerebral artery territory and posterior cerebral artery territory is spared. So this is definitely a MCA stroke. As I scroll down, you will notice more and more parts of the frontal and parietal and temporal lobes are being involved. The deep cortex is also involved. The internal capsule, the putamen, globus pallidus, the deeper basal ganglia stuff is involved. So this wedge-shaped hyperintensity in DWI, and as I already told, everything that looks bright in DWI doesn't necessarily mean it's in stroke. It should have a corresponding low signal intensity in ADC, and voila, this is the ADC. And the thing that is bright in DWI is also dark in ADC. This definitely means that the water molecule in this part of the brain is not diffusing. It's not coming in and out of the cells because of the severe hypoxia and ATP deficiency. The sodium potassium ATPase are not working. The cells have locked in all the sodium within themselves, potassium out of themselves. Water is not moving in and out, and what this imaging does is it picks up the water that moves up in and out, and because the water is not moving in and out, it is showing bright signal in DWI, dark signal in ADC. So this is a stroke. Now we know that it's a stroke of MCA territory, right? Because ACA is preserved, PCA is preserved, the wedge-shaped infarct of large territory of parieto-temporal lobe is involved. As I scroll down, some part of temporal lobe is also involved, as I can confirm in ADC. Okay, now the thing is, how will I know how old the stroke is? Is it 6 hours, 4 hours, 3 hours, 24 hours, 52 hours, 72 hours? How will I know? So for that, I will check upon T2 images. So what I do is, where is T2? I will find T2, and then I will bring one of them down. So this is, as I bring this, so now this image is the T2 image, and I will look for any signal intensity in T2 as well. And as I look, everything looks symmetrical. Those part of the brain which has signal intensity changes in ADC does not have any change in T2. That means this is a hyperacute stroke. It has not been more than 6 hours of this stroke to happen. So we are in the window period. Something that can be done, everything that can be done to resolve the clot will lead to reperfusion in this part of the brain, and maybe a long-lasting deformity can be prevented. So this is a golden period. This patient has had a stroke for not more than 6 hours, because after 6 hours you will start seeing changes in T2 as well. But in this case, there is no T2 changes. There is only diffusion restriction, and that is the reason why it is less than 6 hours. It's also called a hyperacute stroke. Okay, now which vessel is involved? For that, we will look at angiogram of this case. So this is the angiogram. Let me magnify it for you. As I scroll, there are two anterior cerebral arteries which are well opacified, which are well visualized. So no problem in ACA of either sides. You can see they are running anteriorly. And then I scroll down. This is the middle cerebral artery on the left, which is well opacified, well visualized. But however, as I look for the symmetry on this side, I don't find any MCA. And that's the reason why I'm confirmed that the middle cerebral artery of right side is been involved, is completely occluded by a thrombus. And as I scroll down, I find the internal carotid artery on the left, which is well visualized. However, internal carotid artery on the right is not visualized. See, the internal carotid artery on the left, there's no internal carotid artery on the right. It's not visualized because it is occluded. Okay, and as I scroll down and down and down and down, you see there's well visualization of ICA in the left, not so good visualization of ICA on the right. And as I go down and down and down and down and down, I find that the ICA from the cervical segment is completely occluded. So this is a very good case of right middle cerebral artery malignant infarct. There's a word called malignant infarct. If it is involving a large territory of the brain, it is also called as malignant infarct. And this word has been emphasized because of the fact that a large area is going to die, and it is going to be followed by a perilesional edema in 3 to 5 days. This patient might develop severe edema in one side of the skull and will cause severe midline shift, increase intracranial pressure, and can cause morbidity and mortality in this case. And that's why it is called malignant infarct. If there is infarct of a large territory, it will be called a malignant infarct. So I think that is it for today. We will talk about something more interesting in next videos. Thank you.